When we solved systems by graphing, we found that there were some limitations. So the next step is to solve algebraically. One way to do that is by elimination. To eliminate means to get rid of something. When two variables have the same coefficient, they can be eliminated by subtraction. Elimination can be one of the easiest methods to solve because you can get rid of one variable, or you can get rid of a variable that has the larger coefficients. All right, let's look at the search example. Randy has some $1 bills and $5 bills in his wallet. He has 15 bills in all. He counts the money and finds that he has $47. How many of each type does he have? Okay, I know that we don't have to write this, but let's just look at what we know for practice. So we know one of our equations has to deal with how many, or the amount he has. He has 15 bills in all. So that's going to be our first equation. And then the second, how much money, that's the $47, and it's $1 bill and $5 bills. So that's our second equation, x plus 5y equals 47. So add the equations by adding the like terms. Describe the result. Can you solve the resulting equation? Why or why not? All right, I'm going to line these up just like I would any kind of problem. I'm going to put the x's under the x's, the y's under the y's, and the constants under the constants. Okay, I've got everything lined up. Now it says to add the equations by adding like terms. All right, so I'm going to put my 1 in front of my x here, so I'm going to add this whole thing. 1x plus 1x is 2x. 1y plus 5y is 6y. And 15 plus 47 is 62. Did that help us solve anything? No, because we still have two variables. So no, we cannot. We need to eliminate one of the variables. All right, so this time we're going to do the same thing, but we're going to subtract. Remember over here, this was all addition. We added, but now we're going to subtract. So I'm going to write the equation again. I'm going to write my ones in there, but you don't have to. And then I'm going to minus 1x plus 5y equals 47. Okay, so when I do this, I need to distribute my negative here. So this is a key step to distribute a negative sign. All right, so that becomes negative 1x, negative 5y, and negative 47. So when I do that, now I have 1x minus 1x. Those are eliminated. Then 1y minus 5y is negative 4y, and 15 minus 47 is negative 32. So now I can solve for y, divide by 4, so y equals 8. Can I solve the equation? Yes, I solved for 8. Now if I wanted to find out what x was, I could just plug it in. So going on to the next page, what are the steps in solving a linear system by multiplying first? First, make sure each equation is written in standard form, which is ax plus by equals c. This is a good time to note that if you are given a system that is written in standard form, then elimination is a good strategy to solve it. But if you're given a system that's written in slope-intercept form, y equals mx plus b, then graphing might be a better way to solve it. All right, moving on to step 2. You need to multiply or divide one or both equations so that one variable has identical coefficients. And I'm going to say that this is sometimes not necessary if the system already starts with opposite coefficients. Once you have multiplied so that you have the same coefficient, you're going to subtract the equations, remembering to distribute the subtraction symbol to all terms. I'm emphasizing that last part because this is the most common mistake. Students will distribute to just the coefficient that they're trying to eliminate and not every term. Step 4 is to substitute the value of the variable you solved for back into the original equation to solve for the other variable. When you substitute, you can choose which of the two equations you want to solve for, so just pick whichever one is easier. And step 5, of course, is to check your answer. And when you check, you can substitute it into both equations, and if it is correct, then it'll work for both. And just one last note, remember that a solution to a system of equations is written in an ordered pair x, y. Okay, so those are the steps. Let's practice referring to these steps along the way. I'm going to zoom in on example number 1. Step 1, make sure each equation is written in standard form. Ax plus by equals c. They both are. So step 2, multiply one or both equations so they have the same coefficient. So what I'm looking at here is that I can see already that I have a positive 3y and a negative 3y. So the coefficient is 3 in both cases. Now they're not identical, they're opposite. That's actually really good because that means step 3, subtracting, they're already opposite, so we don't need to distribute a negative. We can just take these two, since they're opposites, and they cancel out. So we're going to move on from there. Now remember that we are adding as we go down. So we have 4x plus 2x is 6x equals 16 plus 8, which is 24. To solve for x, I'm going to divide by 6, and I get x equals 4. That's half my solution. So now I'm going to plug that back in to either equation. It doesn't really matter. Both are about equal in difficulty, so I'm just going to plug it into this one. 2 times 4 minus 3y equals 8. So 2 times 4 is 8, minus 3y equals 8. Subtract 8 from both sides. And watch your sign here. I've got a negative 3y equals 0. Divide by negative 3. And y equals 0. So my ordered pair is 4, 0. Now I'm going to plug that back into both equations to make sure that it works. So the first one was 4 times 4 plus 3 times y is 0. It's supposed to be in parentheses. Equals 16. So I've got 16 plus 0 equals 16, so that checks. The second equation was 2 times 4 plus, minus, couldn't read my own handwriting there, minus 3 times 0 equals 8. So that's 8 minus 0 equals 8, and that also checks out. So our solution is 4, 0. It's worth noting that the solution I used to just eliminate these right off the bat is just one possible way of doing it. You might have chosen to multiply the bottom here by 2 and eliminate your x's. If you did that, you would still get the same answer as I did because you're still following all the proper rules of solving equations. So there's more than one right way to do these. All right, moving on to the next system. Negative x plus 2y equals negative 8. X plus 6y equals negative 16. This is a good example of when you notice right away that you have two coefficients that are opposite from each other, that this is perfect for elimination. So I'm just going to line these up. Remember, negative x and positive x eliminate or cancel out. So I have positive 2y and positive 6y equals 8y. And negative 8 and negative 16 is negative 24. Divide both sides by 8 to solve for y. So y equals negative 3. Now I can plug that into either equation. It does not matter. I'm going to pick the second one down here just because there's fewer negative signs and I prefer fewer negative signs. So x plus 6 times y, which is negative 3, equals negative 16. Let me scroll here. So x minus 18 equals negative 16. Add 18 to both sides, and I get x equals 2. So I'm going to write my answer as an ordered pair, and it is 2, negative 3. I'm going to check my answers by plugging this into both equations. So the first one is negative x, and our x is 2, plus 2 times y, which is negative 3, equals negative 8. So negative 2 minus 6 equals negative 8. That checks out. The second one is x, which is 2, plus 6y, which is negative 3, equals negative 16. So I have 2 minus 18 equals negative 16, and that checks out. Moving along to the next problem. In this example, 3x plus 5y equals 6, negative 4x plus 2y equals 5. I don't have any coefficients that can automatically eliminate, so I'm just going to have to make a decision. I'm going to eliminate my x's here. So I'm going to multiply the first equation by positive 4 and the second equation by positive 3. This kind of reminds me of when you're trying to find a common denominator. It's the same kind of principle where you're multiplying both, in common denominator terms, both fractions by opposite numbers, and in this case, both terms by opposite numbers. So when I distribute this 4, remember it's going to go to each term. So my new equation is going to be 12x plus 20y equals 24. And in my second equation, again, I'm multiplying by all terms. 3 times negative 4x, that gives me negative 12x. 3 times 2y plus 6y, and 3 times 5 is 15. So what happens here is you see how we have our opposite coefficients here. So these are eliminated. 12x minus 12x, that's eliminated. So now we can move on to 20y plus 6y, which is 26y, equals 24 plus 15, which is 39. Now I can tell here I'm not going to have a whole number, so this is another reason that we wouldn't really want to graph this, because our answer would not be precise. So 39 divided by 26 is 1.5, and I prefer decimals in this case, but you can use fractions if you're more comfortable with that. So now I'm going to plug that 1.5 bin back to one of the original equations. So when I say original, I mean one of these, not one that you've multiplied by. Because if you made a mistake going from the step 1 to step 2, you might not catch it if you substitute into the second set of systems. So go back to the original equation, and I'm just going to pick the first one. So 3 times x plus 5 times y, which is 1.5, equals 6. So 3 times x plus, and 5 times 1.5 is 7.5, equals 6. So to solve for x, I'm going to subtract 7.5. So 3x equals negative 1.5 divided by 3, and x is negative 0.5, or 1/2 if you prefer. So my solution is negative 0.5, 1.5. And again, when you substitute those back in, go back to the original problems, these right here. So I'm going to do 3 times x, which is negative 0.5, plus 5 times y, which is 1.5, equals 6. And ordinarily I would just do these in my head, but I am going to use a calculator, and I see that it checks out. 6 equals 6. And then the next one, negative 4 times negative 0.5 plus 2 times 1.5 equals 5. So that's 2 plus 3 equals 5, and it checks out. Continuing on, just a few more practice problems. In the next example, zoomed in a little too much there. They're both written in standard form and everything's lined up correctly. I don't have any identical coefficients, but I do see here that my negative 4y and my positive 8y, this is going to be best to work with. The reason I say that is if I multiply just the first equation by 2, when I distribute this to each term, I'm going to get 10x minus 8y equals 6. So see, I only have to multiply the first equation. So now my positive 8y and my negative 8y eliminate. I didn't have to multiply the second equation by anything to get there. Then just add vertically. 2x plus 10x is 12x equals negative 2 plus 6 is 4. Now I'm going to divide both sides by 12. So I get x equals 1/3. I know I said I prefer decimals, but this is a repeating decimal, so we're just going to leave it as a fraction. Then I'm going to substitute that back in, and there's not really a better one here. If I had a coefficient of x that was compatible with 3, I'd pick that one, but neither one is really better than the other. They're kind of both just awkward since we're multiplying fractions here. All right, so 2 times x, which is 1/3, plus 8y equals negative 2. So I've got 2/3 plus 8y equals negative 2. So I'm going to subtract 2/3 on both sides. So I get 8y equals negative 2 and 2/3. I'm going to bring this up here, rewrite it as 8y, and I'm going to write this as an improper fraction since I'm about to have to divide by 8. So that's going to be negative 8/3. Then if I multiply by the reciprocal, times 1/8 times 1/8, those eliminate right there. Y equals, and then I can see these are going to cancel out here. Y equals negative 1/3. So my solution is 1/3 and negative 1/3. All right, next problem. 3x plus 2y equals 8. 2y equals 12 minus 5x. This is not written in standard form, so that's the first thing I have to do. I'm going to move this 5x to the other side so I can have it 5x plus 2y equals 12. So then if I see this one and my first equation, I'm going to line it up vertically. 3x plus 2y equals 8. This one's a good candidate for elimination because I've got identical coefficients here. So I'm just going to subtract my second equation. So remember, when you multiply that negative, it's distributed to each term. So that becomes negative 3x, negative 2y, and negative 8, which gets us our goal of eliminating 2y and negative 2y. So I have 5x minus 3x is 2x, and 12 minus 8 is 4. Divide by 2, and x equals 2. And at this point, if you chose to multiply the first equation by a negative, then you should see that you've still got the same answer as me, but your work is going to look a little different. Now I'm going to plug this 2 into one of these equations. I'm going to pick the first equation just because I think it looks a little nicer. So 3 times x, which is 2, plus 2y equals 8. 6 plus 2y equals 8. Subtract 6. 2y equals 2. Divide by 2. And y equals 1. So our solution written in as an ordered pair is 2, 1. Last example on these. 3x equals negative 6y plus 12. That's not written in standard form, so I'm going to add 6y on both sides. And I get 3x plus 6y equals 12. And the second equation, negative x plus 3y equals 6, is already in standard form. So I don't have anything that I can obviously eliminate here. I do notice that my negative x and 3x, those are kind of potential for opposites here. So I'm going to choose to multiply my first equation by 3. So distribute that 3 to each term. So 3 times negative x is negative 3x. 3 times 3y is 9y. And 3 times 6 is 18. And again, you do not have to do it the same way that I do. In fact, I encourage you to find a different way and see if you get the same answer as me in the end. So our 3x and negative 3x are eliminated. So 6y plus 9y is 15y equals 30. Divide by 15 to solve for y, and y equals 2. Now when I plug that in, I'm going to go back to one of my original equations before I did anything, so that if I did make an error, I will find it. So I'm going to use the bottom equation, negative x plus 3 times 2 equals 6. And I just chose that because the coefficients are a little bit smaller, but again, if you do all the steps correctly, we should get the same answer either way. Negative x plus 6 equals 6. Subtract 6 from both sides. Scroll up a little bit here. Negative x equals 0. Divide by negative 1 if you want. We can see that x equals 0. So our ordered pair is 0, 2. And if you get an answer like that, you think, I'm not really sure if that's right. This is a really good one that you should definitely check if you feel unsure. So 3 times x, which is 0. Whenever I get 0 for an answer, it makes me a little bit hesitant. Did I do something wrong, or is that just really the answer? Negative 6 times 2 plus 12. So 0 equals negative 12 plus 12. Well, that works out. And notice I went back to the original equation that was given before we wrote it in standard form. And then I have negative x, so negative 0, which negative 1 times 0 is 0, plus 3 times y, which is 2, equals 6. So I've got 0 plus 6 equals 6, and it checks out. All right, let's look at some word problems. When we did the graphing problems, there were a couple that were such big numbers that doing them algebraically might have been preferred. So now that you know how to do them algebraically, you will probably prefer this way when you are working with large numbers. A landscape designer uses 2 types of gravel for walkways. The larger gravel weighs an average of 48 pounds per cubic foot, and the smaller weighs 40 pounds per cubic foot. In his truck, the designer has a 12 cubic foot load of gravel that weighs 520 pounds. How many cubic feet of each type of gravel are in the truck? When we discussed writing equations, we said there's often 2 different types. The amount, which is 12 cubic foot load, and then how much, in this case, is how many pounds, not the price per pound like the last one. It weighs 520 pounds, 48 pounds per cubic foot for the small, or the larger, and 48 pounds per cubic foot for the smaller. I'm going to start by defining my variables. I like x and y, so I'll call x the larger and y the smaller. All right, so our first equation is the amount. So the designer has 12 cubic feet. So x plus y, large plus small, totals 12 cubic feet. And then the second is about the weight. 48 pounds for the larger, 40 pounds for the smaller, and the total, there it is, 520 pounds. So 48x plus 40y equals 520. Okay, so I can't eliminate unless I do some multiplying. So I'm going to choose to multiply the first equation by whatever is going to be easiest. So my coefficient for x is 48, my coefficient for y is 40. I'm going to choose to use the smaller number. So I'm going to multiply by negative 40 so that I'll be able to eliminate those. So remember to distribute to each term. So now I have negative 40x minus 40y equals negative 480. I'm going to line up my second 48x plus 40y equals 520. Has a pitiful equal sign there. Equals. Okay. So my negative 40y and my positive 40y are going to eliminate. So now I can just combine like terms. Negative 40x and 48x is 8x. And negative 480 and positive 520 gives me 40. So x equals 5. Now when you're going back to plug that in, I think there is a clear winner here. We're going to use the first equation. 5 plus y equals 12. So y equals 7. So how many cubic feet of each type of gravel are in the truck? So we've got 5 cubic feet of the larger type and 7 cubic feet of the smaller type. Next question. A toy maker produces wooden trains and wooden airplanes. Each train requires 3 ounces of paint and each airplane requires 5 ounces of paint. The toy maker has a gallon can of paint, which is 64 ounces. Glad they did that so I don't have to do the math on that. If he wants to use it to paint 14 toys, how many of each can he paint? Let's highlight the important information first. So we know we have wooden trains and airplanes. So the trains require 3 ounces and the airplanes require 5 ounces. He's got 64 ounces. I'm going to ignore that gallon because we know it's in ounces and that's what we need to know. And he's got 14 toys total. How many of each can he paint? So let's start with our amount. Well, let's first start with defining our variables. So I'm going to call X the trains and Y the planes. Okay, now I'm going to do my amount. He's got enough paint to do 14 toys, or he wants to paint 14 toys. So X plus Y, in other words, trains plus planes, equals 14. And then the next is the amount, or ounces of paint. So a train is 3 ounces, and a plane is 5 ounces. And 64 is our total. Now when I'm looking at elimination, whenever I have a coefficient right here that is 1, it's pretty easy to just multiply this. So if I want to eliminate my x's, I need to multiply the top by negative 3. And that will give me negative 3x minus 3y equals negative 42. And then I'm going to line up my second one, 3x plus 5y equals 64. And combine like terms, so as I'd hope, my negative 3x and my positive 3x eliminate. So then I have negative 3y and positive 5y, which is 2y, and 64 and negative 42, which is 22. So y is 11. So when I go back here, I've got my x plus y, which is 11, equals 14, which means x is 3. So how many of each can he paint? 3 trains, 11 planes. Last comprehension question: when solving a system by elimination and multiplying first, how do you determine the numbers used to multiply in each equation? Well, that's the important part that students get stuck on. You want your two variables to have the same coefficient, so pick whichever numbers that you need that will result in the desired product.